Hello, calculus students. In this problem, we need to work with the dot product. So I'm going to break this into three parts here. We are given these vectors up here, and we have to perform the following operations with the dot product. Right? So in part A, we have C dot A plus A dot Y, and remember that the dot product is commutative. So that means I can change the order of the multiplication and write it as a dot c plus a dot y. Now I did that so it would become evident that I can factor out these a's here, and I do so here, and then it's just a matter of adding the two vectors, which I find easier to do than having to do twice as many multiplications. So I do that. Now I substitute the vector a in here, and I substitute c here and y here, and then I just perform this addition. And remember, with adding vectors, we just add component-wise. So I have 2 minus 8 is a minus 6, and a 7 minus 3 is a 4. And then recall that I dot I, right? So in 3 dimensions, right? This is 1, 0, 0 dot 1, 0, 0. So when we do the dot product, we are just going to multiply component-wise and then add. So, oops, sorry here. I have a 1 times 1 plus 0 times 0 plus 0 times 0 for each of the components, and I'm just left with 1. In other words, I dot I, this is the same as the magnitude of I, the vector I, squared. Likewise, if I take I dot j, I'm going to get 0, because that's going to be 1, 0, 0 dot 0, 1, 0, and the ones never are aligned. So it's 1 times 0, I did that again, plus 0 times 1 plus 0 times 0, and of course I'm left with zeros. So that means we're going to have cancellation with the j's and the i's and the k's and the j's and so on. So the only thing that's going to survive here is the 3j and the 4j when we multiply. So if you were to FOIL that out, you'd have a j times I and a k times j. Those are zeros. And then you'd have a k times I, that's a 0. The only thing that's left is the 3j times the 4j. And so I just multiply the 3 times the 4, and I get a 12. And then j times j, of course, is 1. So my dot product is a scalar, and it is 12.